Water of crystallization means the water trapped inside a crystal which allows it to maintain its structure. Water of crystallization can be driven off by heating, so if I heat a crystal strongly enough, the water of crystallization evaporates out of it. The water of crystallization is represented with a dot next to the formula, in this case dot X H2O. If you don't know the water of crystallization, you can calculate it using experimental methods. Any salts which have water of crystallization in them are described as hydrated. If I heat the crystal strongly enough and drive off that water of crystallization, then the salt is described as anhydrous, which means without water. The apparatus required for this experiment is very similar to that of the magnesium oxide experiment. We need a heat-proof vat, a Bunsen burner, a tripod, a clay pipe triangle, and an empty crucible. The measurements we're going to make are the empty crucible, the crucible with the hydrated salt, and the crucible after heating with the anhydrous salt in it. So let's weigh the empty crucible to start with. And the empty crucible weighs 17.23 grams. So here's my sample of hydrated magnesium sulfate. I'm going to pour that into our crucible, which I've weighed. And I've recorded the mass of that crucible on the board behind me. Now we're going to weigh the hydrated crystal and the crucible together, making sure the balance was at 0 beforehand. And it comes out at 24.69 grams. I'll pop that back on the clay pipe triangle to be heated up, and I'll record the value behind me. So now we're going to heat the crystal with a blue flame to drive off the water of crystallization. So now we're gently heating this until we've driven off all of the water of crystallization. You can hear the water being driven out of the crystal and touching the hot sides of the crucible just before it turns into a gas and evaporates into the air. If you heat this too strongly, there's a chance that it could split. I can see that as the water's generated, the crystals are collapsing because the water of crystallization is very important for a crystal to hold its structure. I'm going to heat this for a few minutes until I can hear nothing more and I can see no more water being evolved from the crystals. At the moment the water's coming out and I can see it on the surface of the crystals as it's heated. Probably hear the water boiling and evaporating from the white crystals. It's been a couple of minutes and the edges of the crystals are starting to turn to a white powder as they're being anhydrous, losing their water of crystallization, turning into a white powder. That's a clue that the water of crystallization is being driven off. This experiment doesn't take quite as long as the magnesium oxide experiment because we're just evaporating water once we've driven it out of the crystal lattice. So it's been a few more minutes now, and you can hear probably by now that a lot of the fizzing has subsided. That means a lot of the water has been driven off from the hydrated crystal. Okay, a few more minutes has passed, and no more sound. The crystals have turned to a white powder. I can turn the Bunsen burner off now and allow it to cool down completely before taking a measurement. So this is what the crystals look like after they've been heated. These are white anhydrous powdery crystals of magnesium sulfate. They've lost a lot of their structure because the water of crystallization has been driven off. You might also be able to see on your screen that there are cavities left by where the water vapour has been expelled from the crystal structure. So after about 10 minutes or so, the apparatus is now cool to touch. I can now reweigh this and get the mass. And the new mass of the anhydrous salt in the crucible is 21.04 grams. Now I've taken my readings, we can do some maths to work out the mass of the anhydrous salt and also the mass of the water driven off. The anhydrous salt is calculated by taking the mass of the crucible from the mass of the crucible with the anhydrous salt in it. That gives me 4.11 grams. The water driven off is the difference between the two masses of the crucible before and after heating. The mass after heating is 3.65 grams lighter. That means 3.65 grams of water has been driven off from that crystal. The way to work out X, as in the unknown ratio of water of crystallization to the magnesium sulfate, is carried out in exactly the same way as we would do any empirical formula calculation. Now, one of the steps involves you dividing the masses by the mass of 1 mole. Last time we used the periodic table and simply the mass number, but this time we have more complicated formulae. So this step calculates the mass of 1 mole of the anhydrous magnesium sulfate and the mass of 1 mole of water. Write these numbers down when you do your calculation because they will be involved in one of the steps. The first step is to divide 2 columns with magnesium sulfate and water. We end up putting our numbers in 4.11 and 3.65, then dividing through by the mass of 1 mole for each. The answers are 0.0343 and 0.203 to 3 significant figures each. I've divided through by the smallest number, and I end up with a ratio of 1 to 5.91. 5.91 rounds up to 6, so our value for X is 6. So it's magnesium sulfate dot 6H2O. So we've covered how to work out the empirical formula from experimental data, either for metal oxides or how to calculate water of crystallization using experimental data. You can see these values are never perfect because they're always practically derived. Remember the definition that you're looking for a simplest whole number ratio